Hello everyone, welcome. Today I'm going to talk to you about collections. Okay, very important, powerful function called ChainMap. And I will show you with a very practical example in healthcare. And let's go. We jump in on this Jupyter notebook. So today is day 13, Python and Pandas for data science productivity, about collections, especially about ChainMap. Okay. I'm giving you these references again here. In fact, ChainMap, a significant amount of document I picked up from docs.python.org. And also I run these usually, right? This command to make sure that I have multiple print outputs in one cell. And also I want to keep this version understanding. For the first time, I'm bringing in Python 3.1.0 because that's where the ChainMap is available. Collections package has ChainMap. Okay, so and from now on I'll be using Python 3.10. Okay, a quick introduction about a couple of things. What is a ChainMap? What is its purpose? And also hash function. Because dictionary is also a hash function. Dictionary is also a mapping. Hash function is also a mapping. So chain function is applicable for general mappings in general. Okay. So ChainMap is a class that is provided for quick linking of multiple mappings and work on the multiple mappings. And the other important property of it of that is that the underlying mappings are stored in a list. That list is public and can be accessed or updated using maps attribute. For example, lookup search. The lookup search will happen in the underlying mappings successively until a key is found. In contrast, writes, updates and deletions only operate on the first mapping. Okay, so keep in mind that that is that's a very useful property. You will see in our example. You won't believe that. I actually took much time to put together this topic because I was also actually using this idea in one of my application. Okay. And the second concept I wanted to, I'll talk. And the second concept I want to talk to you is about hash function. That is also mapping. It maps document the values to a key. Okay, and that key is not easy to understand. It is internal to the system. Okay, so that way all the documents are protected. All the data are protected within a system. Hackers cannot access to it. Okay. So here is the hash function. Just call that hash. In this case, I'm just calling the string Netra Sambamurthy. That's my name, and it says the hash value is this, which means this is an ID for this. Remember that, huh? I changed that one Netra Sambamurthy to Netra Sambamurthy instead of Analytics USA TM. Then it comes out with this number. Any small change you make, it will change the ID. Okay, because that's what we want, right? And another beauty of this is, however big the file is, it doesn't matter how big it is. The hash function will get you an ID and you can refer to that file using that ID. In no time you can get back to it. You don't have to verify, whether that is the right document, is that the comparable document and so on. Okay. So it is amazing functionality, but hash is a mapping and so is a dictionary, but I'm going to use only dictionary. But because ChainMap is so fundamental, so general, it works for all kinds of mappings, including a famous mapping called hash. Okay. The other thing is these numbers will change with a different Jupyter notebook. Immediately I went and checked that with this map, with this Jupyter notebook Untitled 7. Just I ran this one, and then you can see the same thing, but the numbers are different. It's negative here, 2 on, it starts with 2 on 1, and this starts with minus 602. Okay, so you can see that here. Okay, here. Okay, minus 602, 2 on 1, and this is minus 602 and 2 on 2 on 1 here. So if you run, that's how you can protect the hackers cannot get to the data. Okay, so that's how the whole system protects our processes. For a great introduction about the hash function, I just thought this one turned out to be a nice one. When I searched for it, again, the hash function is a cryptic summary reference of everything in the input, however long it can be. There are many types out there. MD5, which is used for data integrity, known to suffer from extensive hash collisions, but widely used. Okay. SHA-5 is the NSA, the US government NSA developed. It's a family of SHA constructs and CRC32 is rarely used outside of zip and FTP servers. Okay, in summary, hashing is a useful tool to verify files are copied correctly between two resources. It can also be used to check if files are identical without opening and comparing them. Beautiful, however big they are. That's the main point. Okay, however small changes are and however big they are. To find out more about hashing, please visit the Wikipedia also. This whole thing I picked up from, I think this one is from python.org, okay? But I'm saying here, this is also the foundation for blockchain technology. Hash functions are fundamental for blockchain technology. And a dictionary is a general concept that maps keys and values. There are many ways to implement mapping, and dictionary is one of them. So hash table is a specific way to implement a dictionary. Besides a hash table, another common way to implement dictionaries is a red-black trees. I don't want to go into it, but I'm just saying it because I brought the notes from python.org. Okay, and I want to tell you that let's get into this ChainMap details. Okay, there are a lot of details I have done here. For my own purposes, interests, and so on. When I post it, you can check it out. This is taken completely from either of those resources. Okay, either the Python doc or some other I usually refer here. Okay, so here is the here is the problem. What I want to share with you. Okay, so say there are 3 different dictionaries for 3 drug levels used in a hospital. Okay, for a certain class of admissions. Okay, then you can see already how complicated it is becoming for a class of admissions in a hospital, and now there could be so many other codes about drug level, treatment level, all those things. So these things are very important because this is what connects our data to the interpretability, right? Otherwise the data are coming in some numbers or string, but how do we make sense out of it? These labels are the labels for the keys. The keys are the referring here the drug levels, okay, coded. So the drug level anti-infective drug levels are drugs are coded as the keys here 001, and this should be coded everywhere. Whenever we call it as anti-infective, it should be same, right? And the point is, and also at the same time, a particular definition cannot have 2 keys. Okay, that's a problem, right? You cannot have 2 keys for the same definition. So here is the drug level 1, drug level 2, and drug level 3. Drug level 2 is at the bottom, drug level 3 is in the middle, drug level 1 is in the top in the 3 dictionaries that I am defining. The problem is for data quality, you have to carefully make sure that these are all not miscoded, in the sense that miscoding comes here. If I have some problem, small changes here, I don't worry about it. But if the same code has 2 different meaning, I'm sorry, if the same interpretation is given for 2 different codes, it's a problem. Okay, of course it's a problem even the other way also, but right now I am interested in making sure that there are no different codes are not used for same interpretation. Okay, then that will be a problem in building the models and building the analysis and reports and so on. So that is what I was checking, and you can see it is not something you can do manually, right? And even not only that, it's a serious problem. Okay, and we don't know how many of them are repeatedly made mistakes and so on. So we have to do that analysis. That's what I'm going to do now. There are some workout I did, checking here and there and all those things. I will leave it there for now, but I want to talk to you about I checked the dictionary of the drug level 1, drug level 2. I can use the usual dictionary properties, whether even if I have a chain map also. Okay, right now I'm just checking each of them separately. Okay, then I bring in the chain map. Okay, so it is very simple. From collections I have to import from collections I import chain map. It's up there. Okay, okay, from collections I import, I already did that, that's why from collections I import chain map, but I was doing some various other things also in between to make sure that I personally know what is going on intellectually first. So then I bring in the chain map to do my analysis. I do all these things, but you'll be surprised that within couple of few cells of analysis I have accomplished what I want to do. Okay, even though there is so much notes I have to explore myself to be familiar with the situation, right? So what I did was basically I chained all the drug levels into one massive big dictionary. Okay, and and then I am doing something here. What am I doing? I want to find out, remember, I want to find out if there are two different keys for the same description. If there are two different keys for the same description, okay, that's what my problem is. So what so in order to do that, that means there will be multiple descriptions. There will be multiple keys for the same description. That's what it is. So we want to find that out. So in order to do that, I have to do flipping of the keys into values, values into keys, and then count the number of keys, right? That's what we have to do. So that's exactly what I did. So initially I set up the flip to be empty set, empty set or empty dictionary. This may mean set or dictionary. Okay, remember that. Both of them have the same boundary symbols. So for key comma value in chained collection of drug levels, I work with the items. Okay, for each items in the chain drug levels, take the pair key value. If value not in flipped here, that means for the first time, I put that key into that into that flip, okay, object. Else I append. Once I find that there is there, I cannot keep appending there. Okay. Now, and so that's what I do first. Okay. Remember that will that is just going to collect all the keys now, and now I will find out the length of whatever that values are. That's what I'm saying. So flipped values I take. So it is really a dictionary, and flipped values here I take it, which are really the keys, right? Flipped values, and then I find the length of those flipped values, which are the keys. If it is greater than 1, then that's the only thing I will retain it, filter, okay, through the lambda function. I filter it and then I put it in result. So these are only the keys that have multiple occurrences. That means for the same value there are multiple occurrences, which is a problem, right? And I need to know that. And then after that I also checked, unless I do this deep copy, it's not going to work out. So I take a deep copy of the list of results, okay, and then print the deep copy here. That's what it is, one here, okay, because this will be lost. After I come out of this cell, result will be lost. So that's why I have to keep a deep copy of it in a different way and then work from here. So these are the two codes that refer to the same description, okay, drug description. That's problematic. These are the same two codes that have a different description. Two codes having the same description. Sorry, two codes having the same description. Remember, it may have multiple codes also here. If there are, the mistake is so bad, it could be multiple typos or multiple errors also. Okay, so we found this one, but in order to print what the descriptions are, now I am to use keep these as a keys, and I want to go and print what those descriptions are, because I should see that they have the same description, isn't it? 195 and 065 should have the same description. 137 and 210 should have the same description. That's what I want to print out. I manually checked and it turned out to be exactly same. And but then I don't want manual, so I want automated here. So from func tools, import reduce, because I want to make it a flat list. This one is a list of lists, it won't work as an iterator easily. So I made it into a flat list, and then now I basically apply the get chained drug levels, apply the usual dictionary function get v. Okay, so it's considered as a value. Remember that. Okay, it's considered as a value. Then whatever I get are the keys. But then for v in flat list, I want to get the names here, the value, get the description of the v's. Okay, and that turns out to be 195 is CNS. You can see that these two, 195 and 065, are same, and 137 292 are exactly same. So here is an example, good example, I feel, very practical example. You won't believe this. I'm going to use it for lots and lots of format values to make sure that the formats are properly coded. That's my assignment. I wanted to solve, and it turned out this is an ideal one for me. Thank you very much, everybody. Have a wonderful time rest of the evening, and until I see you tomorrow. So for all those who are following me, be curious and be studious. Okay, enjoy your day, man. Thank you very much. Bye bye.